Hello friends, welcome back to the Dr. TRSDOS channel. I'm your host, Dr. TRSDOS. I just made this video, found out the video didn't record correctly. I only had a black screen. Didn't catch it, I posted it. Now I have to do it all over because I know you don't want to see it without the video. It's bad enough to listen to me talk, let alone without the video. So, after I'd made the video, I jumped back into doing some cleanup here on my desk. But the screens are basically arranged the same as before. The top left screen, this is a Circle M. MinEZ, he calls this product MinEZ. That's from Circle M out of Canada. This connects to the PC that I'm using via USB cable, and the two UARTs then communicate. The two UARTs on board the EZ80 then communicate with the PC. Both are going through the same USB cable. That USB cable also supplies the power, so it's a pretty nifty little product. Serial port on the F91 MinEZ, the standard baud rate is 115.2 K baud. Sometimes it comes up with a different port number each time you plug it in. It's been consistently here COM6 on this. A lot of it depends on your on what's going on with your particular system, but you'll find the COM port that it comes up. It'll come up with two different ones. In this case, it's COM6 and COM9. That's UART 0 and UART 1. We're going to need 0 here for the console. We're connected on 8 none and 1 connection. I'm going to press reset. This is how the Circle M would come up. We then would switch to the C drive. You're in CPM here, so let's switch to the C drive. And then Bill up there is wrote a loader called OS load, operating system load, and then TRS-OS. This will load the TRS-OS operating system, and we get its character base splash screen here, and lets us know we're up. It did a ping, and if you'll notice, the bottom left screen changed. This is TRS-NET, which is a Python-based program I wrote. Runs on PCs. I'm hoping one day maybe we get some help from the user base here, and this could be ran on Pis or Linux-based systems, anything that can run Python. It's connecting to UART 1, which I'm running kind of worst case conditions here, 115.2 K baud on UART 1. We could bump that up. We could go to almost 1 megabit. It works. We have RTS, CTS handshaking. So it's pretty well running error-free. However, I just in the last few days have been adding error correction, detection and correction. So I have error detection and correction working on one side. I needed to get it running on both sides now. But yeah, that's coming along pretty nice. So we have our server down at the bottom. It's got a status screen that shows us what we're doing. I recently removed the code. The status used to update all the time, constantly on IOs. That makes it run significantly slower. I've now changed that to where it only updates on less frequent control commands it receives. Stat, or we have a stat command, and I'll show you that. The stat command will show us how to command the server to update its display screen. So anytime we want to see what the current stats are, we can command it to update the screen. Otherwise, it's not going to update on every read or every write. So looking across the network here, we can see that since I have started this server program, it's done 8 binds, 31 control commands, 3 echoes, 13 pings, 150 reads. I have not wrote to the network drive. Read headers has done 7 and 5 statistic commands. So this server program is coming along pretty well. These two, the center screen here and the bottom right, are folders I have open to facilitate this video. The top center, this is a Zilog Development System, and we're going to be using that through the Zilog Development System in this video. But this is an actual ZDS, ZDS development board, and this is its COM window to the outside world. I have it running at 230.4 KB on COM 12. That's how I communicate with it. However, we'll mainly be communicating in this video with the Zilog Development System itself. On the right, I have the GP200 emulator. They call it the TRS-80 GP emulator version 254. This is a great program, works really well. There's a link for it right there. I've had wonderful luck with it, and it will really emulate a Model 4. I've not tried it for any other models, but it's amazing how close the emulation can come to the actual hardware. Of course, you got a PC with plenty of memory and blinding speed compared to the Model 4, so you can do a lot of tricks. I'll go ahead and exit out of this program. You can see that's in an LS or TRSDOS ready. This computer is mapped with 3 drives. Drive 0 and Drive 7 are hard drive images that I have set up here, which are a file on a PC since everything is virtual. Drive 3 is a disk file. Here I'm using 720K, which is 80, 2 sides, 80 cylinders. The 1.2 megabytes, I've been trying to use them, but 8-inch, 77 cylinders, I've been having some trouble with it. Some of the files are not there. It seems like it's not seeing the storage correctly or something. Maybe it's me. I don't know. I've tried quite a bit, but the TRS-OS can recognize the 8-inch drive, but I'm having trouble getting the emulator to do it. But in this case, I have this set of 80 cylinders, 2 sides. That gives us 720K, same as a 720K floppy. I have that mapped in as drive 3 on this emulator here. And then we have drive 7 as a hard drive. And it's our main data. And we're going to right now go ahead and we're going to disconnect the hard drive. So we're going to need that here in a few minutes. So we're going to disconnect it so we can use the, down here on the bottom right screen, main data, TRS-OS main data is the image file for this drive 7 in the emulator. Okay, this drive 3 is a file on the PC. It's in a different folder I don't have open, but it is mapped to a file in another folder. In that, the Circle M system here that we just brought up, as you can see, our server volume is available, but it's empty. There's no number in there. We know that there's something out there because the ping, a server responded. When I sent out a ping, a server responded, but we don't know anything about it yet. So we're going to hit N here for network. I'm not a professional YouTube video maker, guys, so bear with me. Then we have some commands here in the network utilities. We can hit Q for query. It's going to query the server and learn the volume. Remember before, we know there's a server out there, but we don't know anything about it. So we're going to query it. It tells us it replied. We hit enter. And look what we got. It tells us it has found a disk volume created on such and such date, the exact number of bytes that volume occupies. Then here's the drive code table. DCT, bytes 3, 4, 5, you know. Great. Now we know we got a volume. We want to bind that volume. We hit the letter B for bind. And the server replied that it's now bound to us as network drive 6. Press enter to continue. We also have a couple other commands in here. If maybe you're working on a problem, when you started TRS-OS, it did the ping and it told you there's no servers. Maybe you forgot to turn the server on. You come into the network, you're at the main menu, you hit N, you come into the network utilities, ping. You can do that again right here. Ping. P. Say you want to make sure, you say, that ping, it's a short command and everything, but I want to send a full 256 byte packet, send it to the server, have that server send the exact same packet back to me, and then I compare it. And if what I sent matches what comes back, we must be communicating error free. I'm going to hit the letter E here for echo. You don't have to do this every time. These are just tools I added to give you some tools to test and work with. So E, and it tells you that sent a packet and received the same packet back. I can tell you this command works, and so does ping, because it seems like I've used them a million times because troubleshooting problems. Okay, but now that we've queried the server and bound the server, bind it to us, those are mandatory commands to use the network. Now that we've done that, we come back to this screen. This is going to boot up in VT100 mode. That's fine. Terminal, if you look at 0, it starts using default terminal 4. That's fine. If we didn't, we could hit D, the letter D, and change that default. That's for this session only. But if you want to change the default, and we wanted to use number 2, for example, the adds 25. Let's go ahead and use that. We'll use adds 25. And so you can see the default has been changed to 2 now. We're going to hit 0 and start the system. And we want a password. That's because we've started a terminal session manager. Host 6A for ads terminal. Yeah, this is product of Misosys that came out with the LS-DOS, TRS-DOS 6 series software. And the password is magic, all lowercase. All right, so we have that running. If we do a device, we will see we have drive 0, 1, and 6. 6 came up write protected, where you need to remove that system. Drive equals 6. Write protect equal off. Let's turn the write protect off. 6 is our network volume. Let's look at it. There we have all these neat programs already out there. And guess what? We have those same commands: net bind, net echo, net ping, and net stat. So we don't want to bind because we have already done that. That's why we're running on the network. But that command is there in case we didn't do it at IPL time during that boot process. If we did not do it, we could do a ping. We don't have the query though, so you need to know what you're doing if you try to bind to something that you don't know what's out there. But there could be reasons why you want to do that. So let's try the net echo. And we'll see, and in the bottom left screen, you'll notice that the echo command incremented. It was a 5, now, or 4, now it's a 5. And you saw the status screen update. Let's do that again, and if you watch the bottom left screen, your echo is 5. Now it's completed 6 echoes. Let's ping, net ping. And there you have it. Pings increased, the status screen updated. But just doing reads and writes does not. So we've been doing a lot of, let's say we've been doing a lot of reading, a lot of writing to the network drive. We want to know how many gets and puts that we've done. So it hasn't updated the screen. We've been running and it hasn't been doing any control sequences where it causes a screen update. So, but we want to get the current number of gets and puts. We can use the stat command, net stat. What do you know? It updated the bottom left screen, the status screen, and I guess we need to write something, so you'll see the puts update. So let's say drive 0. We have this ELIZA program. Let's copy that to our network drive. Let's say somebody on the other side wants to use that. Copy ELIZA from drive 0 to drive 6. Now, if we see so far, we've never done any puts, or they're 0. Netstat puts had done 39 writes to the network drive to copy that folder over. Or program, I'm sorry, to copy that file over. So there we have, using the network and starting these systems up and using the network. But how did I get these programs from the Zilog Development System to the TRS-80? Well, there, my friends, is the magic I'll show you now. I'm sure there's a better way to do this, and maybe someone can tell me a better way to do it, because I would certainly love to know. But for right now, to get it started, I wanted to get Zilog over development system programs that I developed in the development system. I want to get those over to the TRS-80 TRSDOS platform so that I can execute the program. Why do I want to develop them with the ZDS? It's although the compiler that assembler that comes with TRSDOS, or can come with TRSDOS from Misosys, you can download for free from 10 man's websites. Although those assemblers really are in some ways more powerful, they do much better job of giving you reports that give cross listings sorted in different ways. They're an assembly language developer's dream. The Zilog Development System, I don't really call an assembly language programmer's dream. It's made to really for C programmers to assemble C compiler output. But it's also a very powerful assembler in that it can handle thousands upon thousands of symbols and pointers and tables. It's not really big on the output that you get. And if you have problems trying to debug or through your listings and things, it's not really the best. It's not like using the old the assemblers in the old days that was they were wrote in like the Misosys assemblers. They were wrote in assembler by an assembler programmer that needed powerful assembler language program assemblers. So they wrote very high quality assemblers that was designed for an assembly language programmer to use. Okay, so that all being said, we're going to bring up our Zilog Development System now. We've talked enough about it. You'll just have to take my word for it that I already have this preloaded. It's ready to load into memory the TRS-OS operating system that runs TRSDOS as a guest. Now you saw that we had these commands, and I wrote these commands so that they are self-contained. In other words, that I could take just those commands, they're binary, and move them out of the operating system, be able to copy them over, and they should run on their own without and just be used as building blocks to link together with other commands. So here on the Zilog Development System, we have at the top some shortcuts. This connects me to the external hardware. There's a board external here that to the PC that has an EZ80 CPU, physical memory, physical UARTs. It's a real computer, not an emulation. So I'm now connected to that hardware, and this red down arrow that kind of goes to the side, that allows me to download my code onto the board to the physical hardware. So it's now in memory. You're on the right. It's now, that program is located, the entire TRS-OS system is now loaded into the hardware. I'm going to make a quick bypass and jump down here. I know that I have the code to do echo. I have that loaded in memory starting at 3000 hex, which is a standard load space for TRSDOS. I have that loaded in, already ready to go. The bind command. Well, I'm going to give you an example here. We're going to move the bind command over to the TRSDOS platform. This could be any code, but we're going to do this command here. So let's see. You just have to take my word for it that I know that it starts loading at 3000 hex, and it's going to, this is the end of the program, the end bind server right here. So the program counter 33 Delta Charlie, this is Charlie, Delta, Echo, Foxtrot, 33 Echo 0, 33 Echo 1. So the code ends at 33 Echo 1. I know it starts at 3000. We know it's now in memory. So we're going to come up here and save to file. I'm going to do a binary save. It would sure save a lot of time, but it forces you to start at physical address 0. If I was doing a hex save, it would allow me to start at any address and end at any address. But when you're doing the binary, it forces you to start at 0. But that's okay. We can eliminate it. So what are we going to call this file? Well, we're going to call it, it's called netbind. And guess what? There's already a file there. But that's because we've already I've done this already, but we're going to do it again. We're going to call it netbind.bin. It's a binary file. Tell it okay. It's saving the physical memory in the binary in the development board to a file in this folder, and right here it is, netbind. I'm going to click on this, and I have a program called HXD hex editor. I'm going to use that to open it. Let's give this guy credit because it's a really great program. I think I've donated to him because I use his product a lot. There it is. I don't know how to pronounce his name, but it's like male horse or something like that, to that effect. Looks like he's in Deutschland, Germany. You can find this program on the internet. There's his website right there. Let's give him a big hand because his product really works well. Okay, so if I look down through here, here's the file I just saved. And guess what? It ends at 33 Echo 1, which is a 03. That's exactly what it was, what we wanted from our assembler listing. If we go back down here and look, 33 Echo 1, the last byte, 0D03. 0D03. This is it right here. But we have all this before, starting at memory location 0 all the way up, but we don't need that. So here's what we're going to do. Edit. Select block. Starting offset 0. Ending offset 2 Foxtrot, Foxtrot, Foxtrot. All right, 1 byte before the beginning where we want 3000. Or 1 byte before that. Select all of that. If we scroll back here, we'll see that that's all. I'm going to hit the delete key. Now, there's the end of our file. It's been truncated down. This is the beginning. This was 3000 right here. Now we want to save this. And we're done with that. Now we have netbind.bin. They created a backup file. We can get rid of that. Now we need to get this file over to the TRS-80 platform. So remember, we disconnected from our image file that holds our hard drive on the emulator. I'm going to open it now. There's a program here. Let's see, let's give credit to Matthew Reed. I'm not sure if he's still around. I paid for this, bought this product a couple of years later. I had some questions or something. I tried to contact him. I never heard back. I'm not sure if he still sells this or does any TRS-80 work, but it's a bang up program. Really works well. I mean, he knew what he was doing, and it allows you to access old your hard drive images or floppy images. One thing I wish it did do would be to support disk files. It does not do that. I really wish it did. The GP200, they did update it to support the disk files, and it's a really minor switch probably to do that. It's pretty easy to support them, but if it doesn't support this program anymore, it may not happen. So anyway, now we want to get this file. We want to add it. Let's get it and put it in there. Netbind. Right? I was already using this directory, so that's why it went straight to it. Normally you'd have to navigate to the folder that has the directory that has your file you just saved. But in this case, netbind, we got it right here. It's going to say it's not a valid TRS-80, and that's fine. That gives us a chance to correct it. We'll take out the underscore, which is not valid. And in this one it's .bin. And in TRSDOS we use the slash instead of the period. And then .bin. Well, it's not a big deal, but we'll call it .cim, which is standard for TRSDOS. TRSDOS does load CIM files. It knows how to deal with them, which stands for Core Image Module. Core Image Module, which is really the exact same thing that .com files are in MS-DOS. They are binary, non-relocatable images, memory images, and that's what we just made is a .com. Only in TRSDOS you call it a CIM, Core Image Module. So we're now going to put that in, and it wants to know if we want to replace this with this. Well, that's because it's already there, so we're going to replace it for our example. We close the Matthew Reed's file reader here. Then on the emulator, we can connect the hard drive, reconnect to our main data platter. Now, if we look on main data, here's our netbind.cim and the timestamp 253, that's us. Okay, that's the one we just put on there. The emulator now has, and that's great. So there's a program called PROCESS that you can download from Tim Mam's website. It's in some of the utility programs, and what it does is process files and allows us to convert between, for example, SIM files, core image modules, to an actual load file. That'd be like a .exec in MS-DOS, an executable file. An executable is a relocatable, loadable file, and it has the information about where it should load in memory. And if not all loadable files are relocatable. If the file was created with an assembler and it's relocatable, then it will have the information in the headers of the load modules telling it where to resolve the addresses internally to make it relocatable. If it makes sense to you. It sounds complicated, but it's not, but it works. It really does work. So this process program, we're going to fire it up here. And I'm going to hit I for image, file, load, and write. Image, load. I'm going to hit L for load. And then we called that net bind /CIN, right? That's now, okay. Now it wants to know the origin of the module. We need it to originate at 3000 hex. That's where we want it to load at in memory, 3000. It's now in the buffer and it has an origin address. Now I'm going to hit W for write the buffer to a disk file. It wants to know if I want to change that 3000 hex load address. No, that's fine. I'm now going to call it net bind /CMD command file, or that would be like .exe in MS-DOS. Net bind /command and hit enter. Oops, I made a little bit of a mistake here. I wanted to show you an example. We'll write it out again. Net bind to drive 3. So my drive 3 here is mapped to the same drive that the circle M over here on the left is mapped to. So if I do a directory on drive 6 over here is my network drive. Net bind file, it's the same file. Tell you what, let's remove it here on the left. On the circle M machine, net bind /CMD. You see, it took it off of drive 6, the network drive. Now, over here, it's still in the buffer. It's still in memory. The one here on the right, the emulator that's running is, I'm going to write it, net bind. Whoops. Net bind /command. I'm going to put it on drive 3, which is mapped to the network. Over here on the right, drive 3 is mapped to the network. On the GP200 emulator. Okay. If I come back over here to the TRS-OS machine, and I now look at my network drive, over here drive 6 is mapped to the network. Are you joking? Didn't I just save it? Okay, so this is written. Okay, the magic of video here. I had to go do some troubleshooting. If you remember when I was writing this file out over here, I was writing the buffer to disk, and then I wanted to put the credits up for whose program I used, and I brought up the about box. That seemed to have interrupted the emulator running and writing this buffer. It didn't like that. If I would have let it run to completion, I'm going to write the buffer again. 3000 is good to use for the starting address. net bind / command. I'm going to put it on drive 3, which is my network folder. And it takes a little bit, so that's why I didn't. If you had to wait until this request file now written, that's fine. We can leave this program open. We can leave this file in memory. Right here we see the buffer size and the buffer used. We can leave this setting here in memory, in this emulator and this program running just like it is, because we're not changing the directory or anything. And then we come over here on the left to our Circle M system that's running. And remember, we said drive 6 is mapped to the network drive, and that's being shared with the one on the right. So now if I do a directory of drive 6, we'll see that net bind command is there that I just saved with that program to the network folder. And we can run it. Let's type net bind. If we notice the status screen on the server, Python server down here on the left, it updated to show we did another bind. It's 10 times I've bound to it. They're closely related now. Okay, so in this video we covered using starting up the Circle M, starting up TRS-OS, starting up we didn't start up the emulator, but using the emulator and then running the process command from Misosys that lets us convert core image modules or binary files, convert that to a load module so we can use it like a command. That's how we bring binary files that we created in the Zilog Development System. That's how we get things out of memory that we have in there and then move them over to the TRSDOS platform. I'm hoping you may be able to make some kind of sense of this video. I realize there's a lot of components here, but we don't do things because they're easy. All right, guys. Thanks a lot for watching. I hope to see you here again.